Hello, this is Mrs. Ross, and this is lesson 24. We are going to be reducing fractions as far as we can reduce them. This is part 2 of that. And we'll see how it goes. So I'm on page 172 of your Saxon Course 2 textbook in the practice set portion. So here we go. Let's see. So this says use prime factorization to reduce. I'm not a big fan because this is hard as it is. So let me kind of show you how I do it. And it doesn't matter to me how you reduce a fraction as long as you reduce it to its lowest form, whether you use prime factorization or not. So I look at 48 and 144 and I think they're both divisible by 12. So I'm going to give that a shot. 48 divided by 12 is 4. 144 divided by 12 is 12. And you can see I'm not done yet, right? Because 4 goes into 12. So let's do 4. So 4 divided by 4 is 1, and 12 divided by 4 is 3. So this is my final answer. So you just kind of divide until you can no longer divide, is my theory. 90 and 324, let me see if 324 is divisible by 9. I don't remember the divisibility rule. It is, so let's divide both by 9 and see what we get, okay? So divided by 9, divided by 9. 90 divided by 9 is 10. 324 divided by 9, which I did on my calculator, is 36. So we're still not done because both of these are positive. Let's see, 2 and 5 go into 10, and 2 and 6 go into 36, so I'm going to have to divide by 2. So 10 divided by 2 is 5. 36 divided by 2 is 18. Now there's nothing that goes into 18 and 5, so that's as far as that's going to go. All right, find the greatest common factor, GCF, of 90 and 324. So factors of 90 are 1 and 90, 2, 45, 3, 30, 4 doesn't go into 90, 5 does go into 90, but I don't know how much, so I'm going to have to use my calculator on that. 18. I don't know if 6 goes into 90. I don't think it does. Oh, it does. Okay, so that's 50. Oh, I should know because 2 and 3 go in there. So 6 and 15. 7, no. 8, no. 9, yes. And we don't have 9 there yet. So 9 and 10. I kind of ran out of space here. And that's it. Okay, so those are all of the factors of 90. And then 324, we have 1 and 324. I think there's going to be a lot of them. I know 2 goes into it. Let's see, 324 divided by 2, 162. Let me add the numbers and see if 3 will go into it. So 3 plus 2 is 5, plus 4 is 9, so I know 3 will go into it. 324 divided by 3 is 108. Because 2 and 3 go into it, I know 6 will go into it. And I'm doing all of this on a calculator because this is not something I'm going to come up with on my own. Let's see, I know 5 is not going to go into it. I don't know if 4 will go into it, so I'm going to double check. Oh, it does. Okay, so we have 4 and 81. So I have 1, 2, 3, 4. 5's not going to work. 6, let's try 7. Divided by 7. Does not work. And then 324 divided by 8. Does not work. 324 divided by 9, I think I already did this one, is 9 and 36. 10 isn't going to work. 11 isn't going to work. 324 divided by 12 works. So we have 12 and 27. 13, no, 14, I don't know. 324 divided by 14 does not work. And 15 is not going to work. 16 might work. Nope, I think we're done. I think we're done. So I'm going to stop there, and it says greatest common factor. So all of my common factors are going to be 1, 2, 3, right? 1, 2, 3, 6, 6, let's see, 15, 18, 9, 36, 12, 27. I think that is it, unless I'm not seeing something. So 9 would be your greatest common factor here, I think. All right, let's reduce before multiplying. So to reduce before multiplying, something has to be on the top and something has to be on the bottom that you can divide. Okay, so 3, there's nothing that goes into 3 and goes into 8. But 5 goes into 5 and into 10. So what I'm going to do is I'm going to go 5 divided by 5 is 1. And 10 divided by 5 is 2. So let me rewrite this. So I have 1 over 8 times 3 over 2. You see nothing changed, right? Nothing changed as far as the 3 and the 8 goes. Now I can just multiply across. And I shouldn't have to reduce at the end. That's the benefit of reducing before multiplying is you don't have to reduce after. And then 8 times 2 is 16, and that's as far as that goes. Okay? I'm going to use multiple colors on this next one. Okay? So let's see if I can reduce beforehand. So I have 5, and I'm going to choose 15. So if I divide this by 5, I get 1. And if I divide this by 5, I get 3. Sorry. Now, I can't, across the bottom, you see 15, 12, and 10. You don't reduce on the same line. It has to be something on top and something on the bottom. Okay? So keep that in mind. Let's do 9 and 12. So, actually, you know what? Let's rewrite it before we do 9 and 12. So I have 8 times 1 times 9 over 3 times 12 times 10. Okay, now let me change my colors. And let's see what else we can do. We can do 9 and 12. Let's divide by 3, and that makes this 3. And if I divide this by 3, that makes that 4. So let's rewrite this. 8 times 1 times 3 over 3 times 4 times 10. And then we can do it at least one more time with the 8 and the 4. So if I divide this by 4, I get 1. And if I divide this by 4, I get 2. So let's rewrite it again. 2 times 1 times 3 over 3 times 1 times 10. We can keep going here. Let's see. Okay, I'll use red. So let's do 3 and 3 because we are actually going to get rid of those. So if I divide this by 3, I get 1. And if I divide this by 3, I get 1. So we'll rewrite that. 2 times 1 times 1 over 1 times 1 times 10. And then you see I have 2 and 10 I can probably do. So let's divide 2 and 10. Divided by 2 is 1. Divided by 2 is 5. So I end up with 1 times 1 times 1 over 1 times 1 times 5, which gives me 1/5. Okay, hopefully you can follow all of these steps. I'm just dividing. Here's another one we can do the same thing to. So let's see. Let's choose 6 and 3. We're going to divide by 3 for both of them. That makes this 2. That makes this 1. So let's write that out. 8 over 1 times 2 over 7 times 5 over 16. And change color to see if we can do this again. What about 2 and 16? So if I divide those by 2, I get 8 over 1, which didn't change. This is going to be 1 over 7 times, and this is going to be 8, 5 over 8. Okay. Let's choose another color because we can still reduce this because we have 8 and 8. So we're going to divide by 8 and get 1. Divide by 8 and get 1. So I'll rewrite this down here. So I have 1 over 1 times 1 over 7 times 5 over 1, which gives me 1 times 1 times 5 and 1 times 7 times 1. Okay. If this is confusing, then you're in the right place because this is pretty. To reduce before multiplying is a a skill that students typically struggle with. So if you want to multiply all of this out and reduce at the end, I don't have a problem. As long as we all end up with the same answer, I don't really care how we got there. So I'm just showing you one of the tricks of the trade here. And again, if you are currently confused, you're on the right track. We're going to keep doing this for a couple weeks, and hopefully it will be something that you catch on to. And if not, if you don't catch on to it this year, maybe next year, because we're learning, right? We don't know all the answers. So G, factor and reduce before multiplying. So we're not going to factor because that's one of my least favorite things to do. I am going to reduce. So 24 and 36, I know that 12 goes into both of those. So if I divide this by 12, I get 3, and if I divide this by 12, I get 2. So let me rewrite that and see if there's anything else I can do to reduce before multiplying. 2. Okay, and then I see, let me change colors so you can see the, where'd my thing go? There, where is it? Oh, there we go. Okay. So I know that these two are both divisible by 5. That's a divide sign. Okay, so 25 divided by 5 is 5. 45 divided by 5 is 9. So I end up with 3 over 9 times 5 over 2. Okay, I still see something that I can reduce. I'm just kind of looking on the top and on the bottom to see what I can reduce. Let's see. Let's use blue. So I have 3 and 9. I can divide the top and the bottom by 3. So this is 1, and this is 3, and I rewrite this. 1/3, 5 over 2, and I think that that's it. So I'm going to go ahead and multiply that out. 1 times 5 is 5, and 3 times 2 is 6, and that's as far as that goes. Having a little trouble. Okay, last one. Of the 900 students at Columbia Middle School, there are 324 7th graders. That's a lot of 7th graders. If one student is chosen at random to lead the pledge at school, I don't know what happened here, at the school assembly, what is the probability the person chosen will be a 7th grader? Show how to use prime, no, I don't like prime factorization to reduce the answer. So really, my probability that it's a 7th grader is 324 over 900, and then I have to reduce this. Okay, so the first thing I'm going to do is see if 900 is divisible by 324, and it is not. So I know from our previous problems that 9 will go into both of those. So let's try that. 324 divided by 9 is 36, so I can get down to something that looks normal to me, over 100. Okay, now 6 doesn't go into 100, so let's do 2. Okay, 36 divided by 2 is 18. 100 divided by 2 is 50. All right, so I still need to do this. So let's divide by 2 again. 18 divided by 2 is 9. 50 divided by 2 is 25. Okay, so 3 doesn't go into 25, 5 doesn't go into 9, so that is my answer. Again, if you are confused, it's okay. This is not easy. Reducing fractions is one of the difficult parts of this course. So if you're not confused, great. Help a friend. And if you have any questions, please let me know. Have a great day.